It's actually great to be here. I am very excited about telling our story about cloud, and we're actually one of the when we started back in 2010, we were one of the first to use GPU instances, and we were in 2013. We were one of the few companies that leveraged the HIPAA compliant instances of AWS. So I'm basically going to try to walk you through our story of how we went from there to where we are today, and how we're kind of changing the landscape in medical imaging. So just to give you a little background as to kind of what are some of the challenges that we run into right now in the medical imaging space, and really around, there's a few different areas. The first is when we think about radiologists and what they do on a day-to-day basis. They're actually, reading CT scans, MRI scans, X-rays, and it's actually what's happening today is that there's just more and more of these scans. So what we're seeing is a lot of burnout with these radiologists, but also the quality is actually not very good, especially when you get to some of the non-experts in the field. There are a lot of misreads. And this is an area where AI can actually try to help and try to augment the radiologist to try to bring their level of quality up, while not making them burn out. So there's other stats here that I've listed, is that it is a challenge to kind of manage this influx of all the images and how AI is going to be deployed within these health systems. And again, most of the technology out there is still kind of pre-internet days. There's really no concept of cloud native in the mainstream. So Arterys is one of those companies that is cloud native, and I'll kind of walk you through some of what we're doing to kind of change, to go from kind of pre-internet days to kind of post-internet. So what we do is we leverage basically the AI or machine learning models to in specific verticals. So we have AI in cancer to detect, for example, lung nodules. We leverage AI for segmentation, for classification, and again, try to bring up the level of quality, but also try to get a little bit more throughput as well. So on the productivity side, there is an enhancement. In the way our system is accessed is again through a URL, and I'll talk a little bit about how that works on the back end in terms of how do we connect the cloud to actually legacy on-premise systems. In terms of our mission and vision and where we want to go, we every day are kind of driven by this early and accurate cancer diagnosis. That's part of one of our products, and that's what we want to change. Is that if we can get early and accurate cancer diagnosis, it will make an impact on patients every day. We want to enable predictive analytics. So this concept of not only diagnosing patients, but also trying to connect that to treatment and trying to predict how patients will respond to treatment. We also want to ensure that we can, basically democratize the quality of care across organizations. Right now, there are certain organizations that have a higher quality than others. And with AI and with connection and cloud-based systems, I truly feel that we can democratize that. And lastly, I feel like if the systems are connected and we can share data seamlessly, I feel like there's a whole new area of research where we can bring researchers together to do predictive analytics. So how does this work? So the way we connect it into the hospitals is we have a couple different ways to do it. We actually deploy an on-premise appliance, or we can do it through serverless techniques via VPN. And the data from primarily medical images that are sent via DICOM are sent up into the cloud. And then from there, end users, physicians access the images via a web browser, and they can review the results of the AI, and they can modify any results they feel are necessary, because AI is never perfect. There will always be errors. And lastly, we integrate into the workflow, so you can launch in context from, for example, Epic or RIS or any other systems, and then from there they can create the reports, and the reports get pushed back to dictation or whatever other endpoints. So kind of this gives you kind of a high-level schematic of how it works and the data flow. So we kind of go back and forth between the actual on-premise kind of the modality sending us the scanner, the images, up into the cloud, and then the end user is really this browser interface. And we leverage the browser to actually collect ground truth annotations as well, because as they're leveraging the service, we're collecting that information so that we can retrain the algorithms and get better over time. So in terms of kind of what some of the benefits of kind of a cloud-native infrastructure in medical imaging, one is when we go into like sales pitches, when we're trying to sell into health systems, one is the area of compute, and the idea to have really elastic compute both horizontally and vertically. Also leveraging GPUs. GPUs are kind of core to being able to do machine learning training, but also inference. And if you need to do any real-time analysis, you need to have the compute power. And the idea for every health system in the world to deploy GPU clusters is just costly and it's not scalable. The second benefit here is around accessibility, is that if we can truly connect these systems together in a cloud-native way, you can share the information and you can share diagnostic information intelligence across these areas, and people are asking for this. We mentioned kind of seamless workflow and integration, so it needs to tie in into that workflow. If you're deploying a new piece of software in imaging and it's not tied to what they're used to, it just won't get adopted. That's part of the key learning around trying to change per practice. Obviously AI, we're leveraging AI. Not really, we don't think of a machine learning model as a product. Really, machine learning is a tool. We use models to augment the entire workflow. So it's not specifically tied to diagnosis or treatment, but it can be tied to literally reducing the number of clicks or trying to predict what screen should be looked at next. So there's a lot of places where AI can actually offer that difference. And lastly, security. And I'll talk a lot about security in this presentation because it's critical when we go and talk to customers and to just really show that there are values in the cloud as long as we address security in the right way. Part of what we've done at Arterys is leverage kind of a microservice architecture, and kind of very similar to the way AWS develops its core services. You have different teams that communicate via APIs, and that's essentially how we've built our stack as well. And in doing so, we've kind of enabled a way to kind of eat our own dog food. We leverage those APIs internally to create products, to create machine learning models. We leverage the APIs to create user workflows, kind of the user experience. And the idea is that we can make these APIs public. And so we started to do that with partners so that we can take their machine learning models and embed them into our platform. Because the reality is that it's about 5% of the work to create a machine learning model. It's about 95% of work to actually get it deployed into the health system and actually into the clinical workflow. And that's part of maybe not realized by some of these hundreds of machine learning companies, but that's kind of the differentiator, is how can you do that quickly and in a scalable way. So the way we think about our platform is that we obviously have the capability to store the images and to view them, but really the ability to deploy AI at scale, and we develop our own content, and we also license content in order to create kind of an immersive experience within a single user interface. Just to give you some sense of kind of where we are today. So we are fully FDA cleared, and there's a difference between kind of being a medical device and not. So we are considered a medical device. So we have 6 FDA clearances, and we're actually cleared for regulatory use in over 100 countries. And if any of you are interested to know what the regulatory landscape looks like, I'd be happy to talk more, and also what it takes to deploy AWS in each one of these instances, in each one of these countries. Because there's a lot of intricacies involved, because AWS is not in every country, and what it takes to actually work kind of side by side with AWS and with regulators to deploy a medical device that's purely software as a service. So I kind of wanted to highlight one specific customer. So this is an enterprise customer that kind of reached out to us last year. This is a hospital in France. So we have about 50 health systems in the US, but I wanted to highlight one specific one in France because it's actually one of the most challenging from a deployment perspective and from a kind of a cloud deployment and embracing that and sending data into AWS. And so there's other countries that are challenging as well. Actually, the US is actually one of the easiest ones because they have a process called the Business Associate Agreement you can sign, and data is freely shared. But the challenge is, outside of the US, it is not as sophisticated. So Valenciennes had a couple issues that they had to try to solve. And some of those issues were the following. So the country of France needs to, there's actually from the highest level an initiative to try to leverage AI. And so there's really, they had a need to really embrace AI for their master strategic plan. And the idea was to try to connect more of their hospitals together. They needed to make the data accessible no matter where each radiologist was located. They needed for better collaboration because they had pockets of intelligence, of specialists, but the reality is those specialists were only covering a very small territory. So the idea was to try to leverage these specialists that cover kind of the broad region of northern France. They wanted to reduce the number of vendors. Right now, they just can't manage all these vendors coming to them, and so they need a way to kind of abstract that away, specifically in AI. They have a vision to do personalized medicine, to be able to leverage that data to offer insights that are very specific to each patient. And they need to increase the quality of care because right now their radiologists aren't there yet. And so they feel like that AI can augment them and kind of bring that level up for everybody. So how do we do this? So the first thing is what we did is the value proposition for leveraging Arterys was around a few different areas. So around kind of the accuracy piece. So we were able to show through kind of computer-aided diagnostics or CAD that we can increase the accuracy of the radiologists from about 70% to upwards of 98%. On the productivity side, we can show that we can reduce the amount of time it takes to process a case, and we've done that. And also on the IT side, the idea is that to reduce the burden of them managing local servers and infrastructure, and the idea is for them to leverage a single vendor that can do software as a service, and they don't have to manage any of the kind of AI IT infrastructure. So these are some of the specifics around each one of those bullets. So one is we were able to show kind of a reduced reading time, specifically in the case of our lung products. So with lung AI, what happens is we will automatically detect which if there are any lesions or any nodules in a chest CT scan, and we're able to longitudinally track the progress of or growth or shrinking of those nodules over time. And it seamlessly integrates into that workflow so that they can launch in context, side by side with the PACS, or maybe it replaces the PACS viewer. And we're able to integrate the lung RADs, and there's RADs reporting guidelines as well as RESIST, and pushing all of that information into their dictation. So that's what we're able to show, and it did involve a lot of handshaking with some of the other vendors that they had. So they have another vendor called Acetiam, which is kind of a EMR type of company. The next is on our cardiac product. What's typically very tedious is trying to identify where the heart is or where the muscles of the heart is. And so the physicians have to actually draw circles around the inner and outer borders of the heart to try to quantify the ejection fraction or the function of the heart. And it's super laborious, takes about half an hour or longer for complex anatomy. And so we're able to, one thing, prove that without any edits, that we're as good as the radiologist in terms of accuracy, but also in terms of time savings. We were able to prove that in this case, we did a small study that we were 36% faster, so saving about 14 minutes per study and upwards of 25 minutes. So I think over time, we want to prove this more globally, of course, and do more of these studies than just a one-off basis, but it shows that AI is real. It obviously can help, but there's a lot of other challenges, which I will get into. The last thing is that they were very kind of open to the idea of kind of a cloud-native infrastructure. And one thing I wanted to highlight was some of the differences between kind of on-premise versus cloud and versus cloud-native. And it's been actually a lot of education. Every time I go and talk to a customer, I'm not sure they understand the differences between these things, specifically around cloud and the way vendors use that word. Right now, it's primarily storage. And right now, it's primarily used more for kind of remotely hosted instances of software. And it's not really truly a cloud-native environment. So I want to show kind of some of the benefits of truly cloud-native infrastructure. So hospital IT support costs are obviously very high if you have your own infrastructure, and essentially none if it's cloud-native. Upfront capital expenditure with the cloud-native, it's virtually zero. but with on-premise, if you're buying servers, there is initial investment in that. Turnkey processing scalability. So right now, what's happening with a lot of PACS companies or PACS installations is that the volume is increasing, the number of images per study is increasing, and there's a lot of new modalities that are just basically pushing more types of data. So a lot of the PACS are just overwhelmed, so basically from the IOPS perspective, that they just can't handle that. So what's happening is all these PACS companies are coming in trying to support the scaling of that infrastructure, and it just doesn't scale well. If it's truly cloud native, you get that kind of for free, and so that's obviously an advantage. Software update cadence. So when you think about how often, at least in the medical imaging world, like a GE or Siemens or any of those companies update their software, it's on the order of years, every year or even longer in some cases. And if there's bugs, it's a huge challenge and it's a pain. Obviously, with cloud native infrastructure, you can really update every week. So the way Gmail updates, you refresh your browser and you don't even know what version you're running on. And that's really what you get. Same thing with Arterys or Netflix or anything like that. You can get features in very fast and you can patch as well. There's one downside, bugs go in a lot faster as well, so you gotta balance that. The other piece is around communication. So there's truly built-in communication. You can share information outside of the walls of your health system as long as you have the right access controls. Obviously, this is not true of any on-premise system, or it can be added, but it's not native. Servers to maintain and replace, obviously none within a cloud-native option. Redundancy and backup. This is something that obviously with S3 it's built in, and we don't even have to worry about it. But if it is on-premise, you have to deal with the issue of fires, flooding, hurricanes, earthquakes. Like that's a true risk if you're storing and having the backups in the same physical place, or at least even 10, 20, or 50 miles away. Native remote access. So especially if there's a UI with a specific product, if it is cloud native, it's built in with this notion that the network may not be optimal. And so if it's not, and you're leveraging VPNs or remote desktops, it may not be an optimal experience, especially if the network isn't very good. The other piece is around AI and leveraging the data to continuously improve the modeling. That's something that really is a huge pain for AI companies because they're deploying their models on-premise and they have no idea what the performance is. So yes, you can write scripts that try to push out the logs for that out of the hospital walls. Then you got to connect VPNs. You can try to send out your field operations person to try to get that information at every center, but it's a huge pain. Obviously, with a cloud-native system, you get that for free, and we can leverage that data that comes in and learn on a real-time basis. There's one challenge though, and the challenge is the internet connection. So I'm actually going to go into that and how we deal with that. Obviously, access, I mentioned that, security and privacy is still a challenge today, and I'm going to get into that as well. So in the last few minutes, I kind of want to talk about 5 issues that we run into every single day and how we address them, specifically around cloud. So the first is cloud is not secure. So that's unfortunately we're still hitting that issue. And it's around like what are the talking points that we use to try to bust that myth. The second one is cloud negatively impacts patient privacy. Cloud is not performant enough, specifically from the network side. Cloud adds legal complexity to any specific deal, and cloud slows down deployment and integration. So with every one of these, let's start off the top. Cloud not secure. So I'm highlighting a couple things here. So on the left is kind of I don't know if you've all heard of the WannaCry ransomware attacks that were pretty public at some hospitals, especially the NHS, that they were leveraging exploits in the operating system to really hold hospital data at ransom. And that was purely like primarily on-premise attacks on Windows. But there's obviously digital attacks, but also physical attacks. On the right is actually some great video of white hat physical penetration testers that can get into any hospital using garbage. It's everything you're seeing here is just items that they've that they took out of the garbage can, and in about 1 or 2 seconds, they can go around any door. It's pretty impressive stuff. You can watch the videos, but the reality is a lot of these hospitals don't have a lot of physical security, and I can walk into any hospital, cut an Ethernet cable, and I'd be able to see PHI. It's most of the time not encrypted, and it's a more costly attack, but it can be done. In terms of digital attacks, there are several here, but one thing I want to highlight: nothing here is specific to cloud, and I think in general, I know this may disappoint some of you, but I would argue that the cloud is safer with asterisks. Of course, it doesn't really matter. If you can be spearphished even with a cloud-native environment, but in general right now, a lot of the breaches are happening with kind of a lot of these techniques that are primarily on-premise. And in fact, I have some data to support that. By the way, that graphic on the right is it's called an OMG cable. It's a lightning cable that you can plug into any device or just leave it on premise, and it's basically a Wi-Fi chip. And you can just, it gives like remote access into any network. So that's type of attack. The data breaches. So I guess the OCR publishes all their breach information in the last 10 years or so. And of the breaches, just last year, there were about 365. 273 were at the provider level. 53 were from the health plan, and about 39 were from the business associate. And out of those business associates, there were basically 0 that were running primarily workloads in the cloud. That's not to say that it won't happen. For sure it will, but right now it's not happening because there's lower hanging fruit out there. There's a lot easier ways that hackers can get into health systems and leverage exploits. For example, not patching systems. So how do we handle data privacy? So what are our talking points when we address this internally? So we talk about layers of an onion. There's nothing foolproof. If somebody wants to get in, they can. It's just a matter of adding a little bit more layers to kind of slow them down, and adding alerts to know when they've penetrated specific layers. So for us, data is at the core. And then from there, we expand out into security around application, the host, the network, perimeter security, physical security, and at the highest level, policies, procedures, and training. Like most of the attacks happen because your workforce is not trained to address a lot of these kind of social attacks. On the right here, kind of buzzwords that we use all the time. People ask us in security reviews, what do you do with encryption? Encryption at rest and in transit. How do you manage your authentication and authorization controls? What do you do with monitoring? How often do you do penetration testing? How many security engineers do you have? How do you segregate my data so to make sure that it's not touching any other customer's data? How do you handle de-identification? And how do you handle VPNs and firewalls? So those are all buzzwords we use to kind of address their concerns. And this is a great slide. This is real data that shows some of the security reviews that we've been a part of. I think I've been a part of over 150, and what it takes to get through those. From literally hours, or I would say not even hours, literally minutes, which is basically nothing. When you look at Europe, majority of health systems don't have security reviews. They'll have you sign some form potentially, but there's nothing. And on the opposite side, it takes years. At some of the large academic medical centers, it'll take a year, especially when we were the first ones to do cloud. And there's everything in between. So what we're seeing more and more today, unfortunately, is more of these 1,000-question questionnaires. That still takes time. And if you're thinking about scaling and going fast, that's one thing that will slow you down for sure. All right, the next myth, I'd say cloud negatively impacts patient privacy. So we had to create a specific solution to try to remove patient identifiers from all the data that we collect. And it was a big pain. We had to invest like pretty heavy resources for years to create this specific solution that bridges the cloud and the hospital network, and doesn't and in a way where no patient information is in the cloud. And I'd say we had to do it, but I'd say, did we want to do it? Absolutely not. And I think this should stop. I think there are other ways that we can be safe and secure that then just stripping information. Because the reality is, if you're stripping information, it makes it hard to do analytics on it. It makes it hard to predict how these patients progress over time. It makes it hard to connect the same patient across multiple centers. So if that's one ask of the community is, I would love to create a system that we don't have to do this, but still leverage the cloud infrastructure. One way we get around that is some of the controls around where the data is stored. So we have separate deployments. At the highest level, we have kind of a load balancer that kind of directs users depending on where their hospital is located. But that's one way we kind of get around the idea that to keep data secure and within a certain region. This is another myth around cloud adds legal complexity to a deal. So you have no idea how often I am called into reviews of end user license agreements. And the cloud, I would say this may be a truth. The cloud just right now adds complexity to that. When I talk to lawyers, they have no idea what the cloud is, and they're afraid of it, specifically around data and who owns the data. Right now, on the left is some of the crazy requests that they've asked for around having unlimited liability for us, and that we're responsible for the medical diagnosis, that we will provide indemnity if they get sued for anything, that we will say we'll have no warranties, like basically no viruses in our software, that they will patent the data. That was a good one. And the other like governing law in Botswana was once one that I don't know if they have, I don't know, but so there's this crazy request, and I would love for the industry as a whole to kind of move toward more templated license agreements. The BAA, for example, is a fantastic one. It's put up by the HHS. That's very rarely redlined, but that's one where if we can move towards more seamless, kind of onboarding around or more legal agreements, that'd be amazing. The next is kind of cloud not performant enough. Now, I want to show you kind of a live demo and to kind of debunk that myth and show you that even with a limited internet connection, that it's still possible to do very kind of real reads in an environment. So I'm just going to log in here. You can kind of see my screen. So in this case, I'm on a work list, so I'm going to load up a specific study here. So this is a cardiac MRI scan. It has about 5 gigabytes of data, and it loads in just a few seconds. And the way we can do that is we can leverage the GPUs in a parallel way. That's a little chunk of data is deployed on each one, and it can load up very fast. If you have 5 gigabytes of data and you try to load that on PACS today, it's going to take many, many seconds, if not minutes, or if not, it'll fail because it's going through a single pipe. So, so what's happening now is, with 0 clicks, we've automatically identified this as a heart exam, that we can see what the motion of the heart looks like. And again, right now I have all of the information that I need as a cardiologist or as a radiologist to be able to assess this patient. For example, stroke volume and ejection fraction that we'll do automatically. And again, to the point I had before around machine learning is not the end-all be-all. It's a great way to kind of raise the bar, but there's always going to be mistakes. So what I can do is I can make any corrections I want. So like, for example, if I wanted to say that this is half the size, or I can draw a new border, we have all the tools to do that and to be able to correct. For example, it's somewhat more challenging to address where the basal slice is, or where the slice at the heart valve is, and what the contours look like. So when I make those adjustments, all of the numbers update in real time, and they get pushed in real time into dictation. So that's one piece around. That's the benefit of having a unified user experience, is that we can embed machine learning into this experience and be able to capture the edits that users make over time. Because of course there will be always issues with the machine learning. Lastly, I can show you just kind of leveraging the most challenging piece, which is 3D rendering. So in this case, we can do client-side or server-side 3D rendering. In this case, I can visualize the entire data set. In this case, this is the full chest of a patient. The colors here show blood flow. Blue is low-speed flow, and green and red is high-speed flow. And this is called 4D flow. And I can visualize all of this inside a web browser, just leveraging the Wi-Fi. So again, you obviously need an internet connection, but it's absolutely possible. We're doing that every single day with really crappy internet connections. All right, the next piece is around cloud not reliable. So this is an exact message exchange I had with the radiologists. I asked him, how often does your internet go down in your hospital? And they basically said, I don't remember the last time it did. How often does your PACS go down? All the time. So that's kind of one of my talking points to say that it is possible. Now, one way that this can be managed is preventing a network single point of failure. And that's one area that I feel hasn't been addressed in a lot of these health systems, is that if there is still potentially one switch or one router or one ISP, and that can impede a really acute care or emergency care. Now, there's easy solutions to this. With $1,000, you can buy a couple pieces of equipment, and it can be completely redundant and avoid this, but that's not the reality today. In terms of cloud slows down deployment and integration, this is real data of how long it takes to deploy. And so this is the unsexy part around, you have great AI and ML, but what does it actually take to deploy in a hospital? So I have the different tasks here on the left, and what's been our best case, what's been our average, and what's been our worst case in terms of deployment. And you can see some of these are years. And on the right is the people effort, how long it actually takes of people effort to actually make it happen. And the reality is, most of the time, it doesn't really require a lot of people time. It's more the bureaucracy and the politics and the signing of legal agreements that it takes to get a single port opened in a network. So that's kind of part of the challenge, that I wouldn't say cloud slows it down. All of these tasks are still things you would do with an on-premise deployment. But I'm not sure about this question. If any of you have a perspective on that, I'd be open to hearing it. But I also don't have the data on the opposite side as well. So one way we address it is with interoperability. So obviously, the more integrations that we have, the faster these deployments take. So leveraging DICOM, HL7, SOAP APIs, RESTful APIs, the more we have, the faster these deployments get. And lastly, just my last slide, medical imaging is really just the beginning, and we want to be able to leverage the infrastructure, the platform, to be able to support any enterprise imaging, and being able to eventually do a lot of the predictive analytics I talked about. So with that, I'm John Axerio. You can reach me at john@arterys.com.